Okay, so I'm going to be talking today about inverse functions and relationships. So when we take the inverse of a function, all right, so you take something, take a function, it's kind of like we go back to where we started with the function. So f inverse a lot of times puts us back to where we start with a function. And hopefully by the time we go through this, you'll have a better idea. So our goals by the end is to determine the inverse of relations and some functions and graph our functions and our inverses. So here we even have a picture of, in blue is a function and in the red dot is an inverse of that function. And so you can kind of tell that what really happens when we have here, oh I guess I did it in red here, a function and we're taking the inverse of a function is it really just goes to it kind of turns to at a 90-degree angle is really what happens. It's like it turns at a 90-degree angle. So there is a rotational symmetry to this, and we'll get to know more about that. So with an inverse relationship, what we basically do is we swap x and f of x. And for the most part, we're even going to be looking for, we're going to say f of x or y. I guess I do say that there, or the y value. So we're really swapping x and a y, all right, is what we're looking at. So first we have our first equation here is in blue. So this is our blue equation. So you can see at -2, I'm here at the point 2. At -1, I'm here at the point 2.5. At 0, I'm at 3. At 1, I'm at 2.5. At 2, I'm at 2. Then what you do to get my red line or to get the inverse is I am swapping, I am switching, I'm interchanging the x and the y. So what used to be the y is now the x. So these used to be the y's here, now they're the x's. What used to be the x's now become the y's. So it's kind of a flip, a switch, a swap, I guess. So now if I graphed in red here, 2, -2, so here's 2, -2, here we go. Here is 2.5, -1, there we go. Here is 3, 0, there we go. And then here is 2.51 and 2, 2. So that shows us that when we had this blue line, to take the inverse, we got our red line. And if you could tell, that blue line is just, if we tilt our head a little bit to the right, it's just like, oh, okay. And honestly, it's a lot like taking the whole thing. I gotta see if I could do this right. I may or may not be able to, and rotating the whole thing. So it's like if I took this whole thing and I said, hey, I want to rotate. I don't know if I have rotate here as an option. I have flip, but it's not flip, it's rotate. Okay, I want to rotate the whole thing 90 degrees, including the graph is what you're kind of doing, is you're rotating that whole thing 90 degrees. So let's go and say, okay, what if we're just doing by algebra? So by picture, the best way is to come up with a set of x's and y's, swap them out, and then you kind of get the better visual. And so some people are like, oh, I love the visual, I got to do the visual. We also need to know, how do we do this if we're just talking algebraic? So our first step here is to swap your x and your y, or your x and your f of x. So here, we have our original equation here, all right? And I need to swap them out. So I need to put the x where the y is, and the y where the x is. All right, that's my first step. All right. The second step then is now solve for y. All right, solve for x. You want it y equal, so I want y all by itself. So what I'm going to do is I'm going to put kind of this part of the equation. I like to have my y's on the left-hand side. So I'm going to go ahead and do that. I'm going to put that on the left-hand side. Then what would be on the right-hand side actually ends up to be that. All right, so technically what I did was this. I added +5 to both sides, so I got rid of this. And then I said, I really want this on my right-hand side. How do I get rid of my squared now? Well, to get rid of this y + 3 quantity squared, I'm going to take the square root of both sides. So now I have y + 3 equals the square root of x + 5. And then now I have that 3, so I'm just going to subtract that from both sides. So my answer in the end is y equals x + 5 - 3. Is this a function? Well, I know to graph this, it would just be 5 to the left and 3 down, and I'd kind of have this curvy graph like that. And that is a function. It would pass the vertical line test. So the answer is yes, I do have a function. So kind of you have to just get used to what are some rules when it comes to is it a function or not. So let's talk about some is it a function. The biggest rule for is it a function or not is what you can't do. In order to be a function, you can't divide by your variable. Can't divide by x. Can't have x something divided by x. You can't have x in your denominator. This one is going to be not a function if that is the case. For the rest part, you know what? We can do pretty much everything else. You just can't have your x in your denominator there. If it's a visual like this here, you can visually look at it and tell if it's a function or not. So my red line, what I'd be checking is to see if this is a function, my red line, I would say, does it pass the vertical line test? If you remember, the vertical line test says if you cross a line in more than one spot, it's not a function. And since this crosses this vertical line several times in more than one spot, this would be not a function. So sometimes you can look at it visually and quickly tell, and sometimes you kind of have to use some logic when you're looking these through. All right, so we had our algebraic solution. Okay, let's do another one. Find the inverse of f of x equals 2x plus 7. So y equals 2x plus 7. Pretty common type that you're going to have to do in homework. Swap is our first thing. So now x equals 2y plus 7. Next step is to solve for y. So I'd probably subtract 7 from both sides. Now divide by 2. So then my y equals, I'm going to call it 1/2 x minus 7 over 2. That is the inverse. So that would be my f inverse of x. F inverse of x is this. All right, so maybe I should do it. Let's maybe write it a little better here. We could have also used, for 7/2, I could have put 3.5. Now, is it a function? Well, here we have a linear equation here. So yes, linear equations are functions. I'd say about 90% of inverses are functions. You'll kind of get used to absolute value inverses are not going to be functions. Parabola inverses are not going to be functions. Linear inverses are going to be functions. Square root inverses are going to be functions. So you kind of get used to it. So now it's like, okay, we're going back to this type of, okay, how do I graph the function and then look at the inverse? So first of all, let's just graph this function. Let's graph x cubed plus 4. So plus 4 means up 4, and x cubed looks like this. So let's talk about what are some in this original blue, what are some points? So the point 0, 3 is in there. Let's think what happens when I go 1 to the left or 1 to the right. 1 to the left or 1 to the right. 1 to the left, -1 would be -1 plus 4, we'd be at 3. So we were at -1. I should have been right here, actually. This is where I should have been. I should probably kind of erase this and say, oh, I kind of didn't draw that great. And it goes down like this. 1 to the right would be up here at 4. So now let's see what that shape looks like. I'm going to do this inverse in red here. When I switch them, 3, 0, now 3, -1, and 4, 1. So 3, 0 is my point of inflection. So this was a point of inflection here. Now when I go here, it's going to be right here as my point of inflection, 3, 0. And another one I had was 3, -1. Another one I had was 4, +1. Okay, so I have some points there. I got to see if I messed up. 0, 3, 0, 3, -1. Oh, I think I messed up with -1, 3. -1 would still be -3. I messed up. -1, -1. It'd be 3. Oh, it'd be 0, 4. This is where I messed up. I knew I had a mistake here. Sorry, guys. This, sorry, should have been a 4, which means this is a 4. So, which means I knew something didn't look right here. The points here should be 1, 2, 3, 4, 0, 3, -1, 4, and then it should be 1, 5. Gee, I'm really quality control here. I'm sorry, I'm trying to rush. 1, 5. So it'd be 5, 1. So this looks like this, and that looks like that. All right, do I have a function? Yes. You can kind of visually see it passes the horizontal line test. So cubics, when you take the inverse, is going to be a function. Um, and absolute values is not, and we'll get some ideas here of what is a function is not. Let's look at an example here. Number 5. How do we graph it? So I'm going to have you graph the original and then graph the function. So for the original, again, we're looking at cubic. So this one goes up 3 and to the right 1. And then it kind of goes like this and like this. So ones that I always know about is this point is always here and this point is always here. All right, so you go to the left or to the right, you're going to go 1 up or 1 down of your inflection point. So first let's write down my inflection point. My inflection point was at 1, +3. 1 to the left, excuse me, at 0, and 0 is neither positive nor negative, at 0, I was here at 2. At 2, I was up here at 4. So now let's switch them around. 2, 0, and 3, 1. See how I just swapped them? So now I'm going to do that in red here. So I'm going to graph 3, 1, 2, 3, 1. That's my inflection point. 2, 0 would be right here. And then 4, 2 would be up here. So again, I'm just doing this and this. All right, and you can kind of see how your graphs look. Is the inverse a function? Yes, and it always will be for cubics. All right, and maybe we're going to write that down real quick here. Let's do that. Let's write down. So absolute values, let's just look at parent functions. Absolute values, inverse is not a function. Okay. Also, that's the case for parabolas. Inverse is a function. Let's list those. That's the case for linear. We found out over and over again that's the case for cubic. That's the case for square roots. What others did we have? Step. Not a function for steps. We kind of talk about steps. I won't have you graph one of those. Second, third, square roots. I think that's everything. All right. So we kind of have them all about functions. Notice how we're kind of stepping away from 1 over x, y equals 1 over x. For that one, actually the inverse would be a function because you can, yeah. No, it wouldn't. No, it wouldn't be a function. Sorry. Yeah, interesting things there. So give this one a try. We'll have some practice in class. And look for another video that kind of reviews everything that we've covered so far in Chapter 3.